Good morning. This is Unit 3, Day 3, and we're going to talk about log functions and their graphs. So first we need to understand the difference between a log and an exponential. So if a is greater than 0 and b is greater than 0 and b is not 1, then y equals log base b of x. If and only if b to the y equals x, and this is what we kind of write it as usually, log base b of x equals y, and I put the y on this side because then I say, I kind of draw a circle. So b to the answer is now the exponent, is equal to the expression of log. So b to the answer is equal to the expression of log. And this is what the exponential looks like. So we're going to graph something. Maybe it's going to be y equals b to the x power. This is going to look like something like this, right? We know that this is an exponential and it has a horizontal asymptote at y equals 0. There is no vertical asymptote. It goes up forever. I know it's going to go through this point right here, 0, 1. And this right here is going to be 1b, whatever b is, okay? The graph of log base b of x is actually going to look very symmetric. So kind of like this. And this one, there is a vertical asymptote, but there is no horizontal asymptote. It might look like it just goes up very slowly. There is no horizontal asymptote. So this is y equals log base b of x, this graph. And this point right here, instead of 0, 1, is 1, 0. Because they are inverses of one another. So remember, inverses, they are symmetric across the line y equals x. And that's this line right here. That's this line. Y equals x. It's symmetric. So we're flipping it across the line y equals x. So the base property of logarithms, they just want you to see how to change a log to an exponential, or the log with any base of 1 is 0. The reason why we're saying is b to the 0 power, b to the 0 power, anything to the 0 power is 1. So if we have a log base 2 of 1, it's going to be 0. So this one, if the base and the expression are the same, then it's always 1. Because b to the first power is equal to b. b to the first power equals b. So this is going to be 1. Okay, b to the y is equal to b to the y. This is true. Oops. So let's try number 4. So this one is b to the log base b. These will cancel always, because if I take the log base b of both sides, then that is going to be log, these will cancel, and then we'll have log base b of x is equal to log base b of x. These will always cancel, as long as the log has the same base as this. And then you'll just get the expression. Okay, now we're going to actually be able to evaluate these. Usually we can do this without a calculator, and they won't tell us 3. We'll say like 2 to the what power equals 8. Okay, so evaluate the following logarithms. Basically, we're just making this into an exponential. 2 to the third power is 8. So it's true because 2 to the third power is 8. I know that this is 1/2 because the only thing that will make 3 a square root is 3 to the 1/2 equals the square root of 3. That's true. But 1/2 power, or a power that's a fraction, makes it a root. Alright, remember the base to the -2. When we have 5 to the -2, a negative exponent means it should be on the other side of the fraction. So it would be 1 over 5 squared, or 1 over 25. 7 to the 1 power equals 7. And this one, 6 log base 6, we have log base 6 of 11 equals log base 6 of 11. Alrighty, keep going. Go ahead and flip your paper over. They're just going to ask us to graph them and see that they're inverses of one another. Okay? So if I plug in negative 2, this is going to give me 2 to the negative 2. And this means that it should be on the other side of the fraction, which is 1 over 2 squared, which is 1 over 4. If I substitute in 1 over 4 to this, then I say log base 2 of 1 over 4 means 2 to the what power is 1 over 4. And this is going to give me negative 2. 2 to the negative 2 power is 1 over 4. So they are inverses of one another. I'm just going to keep going. Do it again. I have, 2 to the negative 1 is 1 over 2 to the positive 1. If I plug that into this one, 1 over 2, log base 2 of 1 over 2 is going to give us negative 1. Alright guys, 2 to the 0 power is 1. And if you plug in 1 into here, remember that is 0. 2 to the first power is 2. And if you plug in 2 to here, this is going to give you 1. 2 to the second power, of course, is 4. And if you plug 4 into this, 2, it's asking you 2 to the what power equals 4, and this is 2. So these are my ordered pairs, and we can graph them and to see that they're inverses. These are common log problems. We're going to go over these. I want you guys to try these without a calculator. Evaluate the following logarithmic and exponential expressions. So if there is no base, that means that the base is 10. And so it's like a ninja number. It's there, but you don't see it always. So we're trying to get this to be the same base as this. So log base 10 of 100, but 100 I know is 10 to the second power. We can write this actually as an exponential if that's easier for you. But I know that a log base 10 of 10 is 1. We're just going to be the exponent, this exponent right here. So I know that this is 1 times 2 is going to give us 2. Now, log base 10, there's no number here, so I know the base is 10. Log base 10 of 10. The square root means that my exponent is a fraction to the 1/2 power. Remember, this cancels. Log base 10 of 10 is 1 times 1/2 means that this is going to be 1/2. I want you guys to try these and let me know how you do. Make this one. You can check your work on the calculator, but try it without a calculator. It says evaluate this common logs with a calculator. So you guys can just plug this into the calculator. Ooh, let's try solving an equation, because this is kind of new. So we're going to solve this log equation, solve each equation by changing it into exponential form. Sometimes that's going to be how we do it, not always. Remember, we're going to take the base. If there is no base, then it's 10 to the answer is equal to the expression. So 10 to the answer is equal to the expression. 10 to the third power equals x. What is x? 10 to the third power just basically means we have 3 zeros. 1, 1, 2, 3. That's it. Now this one says 2 to the 5 power is equal to x. I think you guys told me last class what this was. 2 to the 5th power is 32. So x equals 32. If I'm wrong, then, tell me, but I think that's it. So we have a special log. It's called a natural log, and we use ln. The base is, it's just a regular log, but the base is e. We use it so frequently in nature, in banking, that we actually made our own symbol for it, and it's ln. So this is the same thing as a log base e. And then square root of e is the same thing as e to the 1/2 power. And the log base e of e will cancel, and my expression, if I want to evaluate this, is just 1/2, whatever the power is. Okay, this one is ln of e to the 5th power. That's the same as log base e of e to the 5th power. Remember, if our base and our expression are the same number, then we're going to be left with the power. Alrighty, let's try this. This is the opposite, e to the log base e, and remember these cancel, and we're left with the expression. So our value is equal to 4. You can use a calculator for this. You can't have a negative log. You can't have a negative inside the expression because it's saying e to the what power will give us a negative number. Even if I have negative powers, they'll just make it a fraction. Fraction. So you're never going to have a negative number. So this one you can say like not defined. The other ones you'll get negative answers. This one you'll probably be a negative answer, but that's okay. But the expression can't be negative. So these will work. Plug it into your calculator, check it out. Natural log has its own button. Basic properties for log, for natural log. This is a natural log. So natural log of 1 is 0 because e to the 0 power is 1. Anything to the 0 power is 1. Natural log is log base e of e is 1. That's what we've been doing because e to the 1 power is e. Remember, we do e to the 1st power is equal to the expression. Alright, e to the y equals e to the y. And this is because natural log of x equals natural log of x. Alrighty guys, I'm going to try one more. I want you guys to go ahead and graph this. I'm going to just pause your video, try to graph it, and then I'm going to go over it. So I know logs have vertical asymptotes, not horizontal, and they always go through the point 1, 0. And they kind of look like this. My analysis is the domain of logs is always going to be 0 to infinity. You cannot include either. My range is actually going to be all real numbers. I go down forever, and I go up forever. It looks like there's an asymptote here, but there's not. Remember, there's no horizontal asymptote for logs. It's continuously increasing. So I'm going to put increasing, maybe like negative infinity to infinity. Usually they want the domain. There's no decreasing. There's really no symmetry. There is an asymptote. So there's only a vertical asymptote for logs, and this one is going to be at x equals 0 on the y-axis. Okay? I don't know what else analysis they want, but maybe end behavior as x, the limit of our function, as x goes to infinity is infinity. It goes up forever. Alrighty, so let's look at how we transform from this graph to this graph, to these graphs over here. So I want to do this one because you're just going to move it to the left 2, okay? We do the opposite of whatever's in the parentheses. This one, do you see that we're doing 2 things? We are going to reflect it because the x is negative, and we're going to shift it 3 units in some direction. What we're going to have to do to see this is we're going to have to put the x first and factor out a negative. Negative parentheses x minus 3. Okay? So it'd be negative x plus 3, and I'm factoring out the negative, so then it changes both signs. And so now I can see that it's reflecting it over the y-axis, because of negative. And then the minus 3 actually means 3 units to the right. So I'm trying to change colors, I use the same one. So 3 units to the right. We need to actually reflect it across the y-axis first. So log, instead of going like this, will now go like this. And then 3 units to the right. So maybe this is 1, 2, 3. This is now my asymptote. My asymptote's moved 3 units to the right also. And remember, it was going this way. So I know that it's going to go through this point right here, maybe 2, 0. And it looks something like this. Check it out and see. You guys can just try these and see what happens. Really, all this one does is shift everything up 1. You know, your 3 is going to be a stretch factor of 3. Kind of have seen these before. Not with logs though, so check them out. These are all I'm going to do today. If you have any questions, please go through and try these. If you have any questions, let me know. Have a wonderful day.